is the stuff at the top here where it says work 4 and 6. That was off the old notes to myself of like, for this lesson I'm just going to work 4 and 6 with you, and we have time to do 1 as well. So in class today we'll do 1, 4, and 6, and then your assignment will be the rest of them. Again, answers are posted, and it's not just answers, but like answers completely worked out are posted. The other thing is, please show work on a separate piece of paper. Don't take that as a challenge. Like, these take lots of room, so I don't want you to say, Mr. Wolf says I probably can't, so I will prove him wrong and write with a microscopic handwriting. No, just get out a separate sheet and let's do number 1 together. In fact, that's kind of a combination of ones we've done. So why don't you take a couple minutes and try that one, and then we'll go over it together. So I take the time to label F prime and G prime. I'm not super comfortable going product rule on the fly just yet. So 3x squared, it's the easy part, plus, here comes the product rule. So FG prime would be x dy dx plus the other way around plus y plus, don't forget the other stuff in the problem. Sometimes people get so focused on the product rule they get it right and then forget there's more to this problem.
Is it y or y prime?
Uh-oh, did I mess something up? I think this is good for right here, because this one is f prime times g, so 1 times y for this one. This one is f times g prime, so that one is x times dy dx. Now he mentioned y prime. If you would rather write y prime than dy dx, you can. It means the same thing. In fact, I'll switch and do that on some of these. It's just some people, when they write y prime, they see y to the first, and then they forget that it's a derivative, and then the whole problem is kind of messed up. So until we get the hang of these, I'm usually going to write dy dx. Once you get used to it, you can throw y prime in there instead, because it's a little bit shorter and a little bit easier. So 3x squared and y are headed to the other side. Minus 3x squared minus y on the other side. And then I'll factor out dy dx from what's left. So that would be x plus 3y squared. And I'm almost done. I'll just divide by x plus 3y squared. So negative 3x squared minus y over x plus 3y squared. Yes.
The one that was labeled at the beginning of the problem, that it was set equal to 1, is that still in the right?
No, because when I take the derivative of everything,
That's 0.
it goes to 0. That's a really good question, though. You might be surprised, or maybe you wouldn't be, given your question, how many times students get all of this hard stuff right: derivative, product rule, chain rule, implicit, and then they forget that the derivative of 1 is 0, and so their answer's wrong because they forgot that one little thing. Now, obviously, partial credit's going to help them out there, but it's just frustrating to grade a test and watch you get all the hard stuff right and forget the easy piece. Other questions on that one? And obviously, the order, so if depending on how you work the problem, you might have had minus y and negative 3x squared in the top. You might have had 3y squared plus x in the bottom. That's all the same stuff. Let's look at number 4. If y equals xy plus x squared plus 1, another constant floating out there just to test to make sure you're paying attention. Find dy dx when x equals 1. All right, why don't you try this one again? At least find dy dx. Do that part first, and then we'll worry about the x equals 1 part. So try to find dy dx by itself. Again, you've got a product rule waiting for you. So yes, that was a -1 up here. Glad you caught that. So derivative of y would be, I'm going to switch to y prime this time just to show that it's completely interchangeable. It's just up to you. Actually, let's take care of the product rule stuff here. So f prime would be 1, and g prime would be y prime. So derivative of y would be y prime. Now I need to do the product rule in here. So fg prime is xy prime plus the other way around, which would just be y. And then I'm back to the kind of the original equation here. 2x and then 0 because the 1 goes away. So most of you are using dy dx because that's the way I did it initially, and that's fine. Again, y prime is good too. It's just sometimes people get light with their pencil and they can't tell if it's y or y prime, or they think it's y to the first, and so it's an easier thing to write. Just be careful. I'm going to move all my y prime stuff to one side. That way I can factor out the y prime. So y prime is y plus 2x over 1 minus x. And again, we're trying to get you used to, in here, reading the directions multiple times to make sure you answer what they ask for. That's y prime, but that's not exactly what they asked for. Find it when x equals 1. So I want to evaluate that at x equal, I did it again, x equals -1. Except that's not quite good enough. What's the problem with trying to evaluate this at x equals -1? There's a y in there, so yeah, I know x, but I don't know y. So I need to find out what y is. So I'm going to come back to this original equation. At x equals -1, I need to know y. So y equals -1y plus -1 squared plus 1. So there's just another little algebra component to this problem. We're done with the calculus, but they wrote the problem in such a way that we had to do some extra algebra here. So move the y over. 1 plus 1 is 2. So y equals 1. So I want to evaluate that now at x equals -1 and y equals 1. So that was kind of a little extra they threw in that problem for us. So 1 goes in for y, -1 goes in for x, -1 goes in for x, and, oh, safe stop, right? Why mess around and mess up negative sign? We're done. And on a problem that lengthy, that might be a free response question, and you could leave it like that. Nothing wrong with that answer. And again, some of you have started to do that, and you left answers like that on the test, and that's good. Multiple choice, 1 minus 2 would be -1, 1 plus 1 is 2. So if you're looking for a cleaned up answer, it'd be -1/2. Calc chat, back of the book, they're always going to do the cleanup work. But free response, leave that stuff alone if you can. All right, I want to do one more with you. Well, definitely one more. We'll see how we're doing on time. But number 6 takes a little bit of space, so yeah, I mean, if you got half a page, you're fine. If you're down to 2 lines left at the bottom of your page, then go ahead and start on the next page. Number 6. If x cubed plus y cubed equals 8, show, that means they're about to give us the answer and they just want us to show the work to get there, that the second derivative so writing the second derivative is a little bit tricky maybe, because the 2 goes with the d, not the y, but in the bottom the 2 goes with the x. Second derivative of y with respect to x. Or I suppose you could just do y double prime and then not worry about it. But show that that equals negative 16x over y to the 5th. Well, some good news, bad news, right? Good news is they gave you the answer, but the bad news is the reason they gave you the answer is it takes a while to get there. They just want you to kind of know where you're headed. Previous years, this has been a test question, or one really close to it. This year, since we're going from block day test to regular day test, I'm having to cut some things, so I don't know yet what's going to get cut, but I'm telling you, as of now, this is on the test. So, gold star, highlight, whatever, to kind of note to self, make sure you know how to do this. All right, second derivative. Well, there's no magic way to get to a second or third or fourth derivative. You just have to take the steps to get there. So job 1 is find the first derivative, and then we'll see where we are after that. So why don't you do that? Why don't you find the first derivative, and then I'll pick it up from there. So take the derivative, move things around to get y prime by itself. So now we got y prime, y first derivative. We want the second derivative, so I need to do, I just need to do the derivative again. What's the major rule that's going to be in play here? Quotient rule. Quotient rule. So f prime, that's easy, negative 2x. G prime, that's not too bad. Why is it not 2y though?
You gotta do the dy dx.
Got to put the dy dx on there, or y prime, either way. Since I went with the prime, like pick one type of symbols and stick with it. You can do dy dx or you can do the primes, but once you decide for that problem, you probably want to stick with it the whole way. So second derivative then is, let's see, gf prime. Gf has to come first. Gf prime, so negative 2xy squared minus the other way, fg prime. So, oh, careful, the minus the negative here. So minus from the equation of the quotient rule, but then also the negative 2x squared y prime, all over g squared, so y squared squared. So there's my second derivative. Right now it looks nothing like what it's supposed to, right? Like we have the answer that we're aiming for, and we've got this equation, and somehow those are supposed to be the same. They don't really look the same yet. I do see that in my answer that I'm aiming for, there's no y primes. It's all x's and y's. So I'm thinking I should probably replace y prime with something. That way I at least get that out of the way. But we have an answer for y prime. So let's substitute this in for y prime. This step happens a lot when you're finding a second derivative, because almost always in the second derivative you're going to have a y prime show up, and so you got to go back and think, okay, well, I know y prime, let me plug that in, and then do a whole bunch of algebra cleanup work. So negative 2xy squared plus, there's my first cleanup work, 2x squared y, and then y prime is negative x squared over y squared all over y to the fourth. You look at what we're aiming at, it's like, well, did that really get us any closer? Not really. I'm trying to get to negative 16x over y to the fifth. I am definitely not there yet. Let's clean up the top a little bit. Maybe we'll get some motivation here. So 2x to the fourth. The y's, though, I end up with a y in the denominator. Well, the denominator of the second term of the numerator. That at least looks a little bit better. Maybe we're getting closer. I don't like the y, I don't like fractions and fractions. So I want to get rid of that y. That's sort of my next target to fix. So if I multiply the top, if I multiply all of the top by y, it would cancel out. But if I do that, I have to multiply the bottom by y. But that's not a big deal. That's a worthwhile price to pay. Oh, plus that gives me y to the fifth in the bottom. So I feel like I'm making progress anyway. So negative 2xy cubed minus 2x to the fourth over y to the fifth. This is a giant algebra problem more than a calculus problem. Again, I keep looking back to where I'm supposed to be headed. Negative 16x over y to the fifth. So y to the fifth looks great. The top does not look great. You guys that use CalcChat, this is where it's helpful. What is CalcChat going to do with that numerator? Do you know? Yes, that's part of what it will do. What else could it take out? An x. So if I take out a negative 2x, that leaves y cubed plus, took the 2, took the negative, took one of the x's, y cubed plus x cubed. All over y to the fifth. Yeah, I don't know. Is that any better than what we started with? Maybe a little bit. The next is quite the trick to, it's not a trick, it's just, do you notice? Look back at the original equation that we started with before we took any derivatives at all. Yeah, it equals 8. X cubed plus y cubed equals 8. And so this sort of magically became 8 right there. If we're really paying attention, the very first thing we said was that x cubed plus y cubed is 8. So negative 16x over y to the fifth. So we got there. Yeah, he's like, no, I don't like that. That's a lot of algebra in that problem. And I really like the problem because there's a lot of calculus in it too. There was a first derivative, a second derivative, a quotient rule thrown in there, a lot of algebra. And so when we have a full hour and a half to test, there's, again, no doubt I leave that problem in there. With only an hour to test, I don't know if I leave that one in there or not. I just have to see. You're voting against it. I can't imagine why. Class vote. You can vote to express your opinion, but the final decision is not with you. So the worksheet is posted. Well, it's posted in Schoology. You may be holding on to it right now. Answers are also posted, and not just answers, but answers with work shown. So tomorrow we'll come in and we'll work a few more of these together, and then we'll get started on related rates.